Another week, another 3 more chapters. I do want to start though by making a reminder that we are about 5 weeks away from the end of the course, about 5 or 6 weeks away. So I know that this is the time when students start ramping up, turning in assignments. So I'm going to do my best to stay on top of the assignments and get them all graded as they come in. Uh, I believe in this course we actually have some buffer time. So if you have fallen behind, you will be able to catch up without any problem. And again, all assignments have one set due date. So you are able to turn in stuff that you have fallen behind on without any consequence. But when that due until date is met, then I won't accept any more assignments. So till then, you are still able to catch up, and I hope you're not falling behind. But if you are, you do have some grace period to catch up. And I know this is when students start turning in stuff, as I know I did it too when I was in college. Life happened, so I am not gonna punish you because life happened. I'm just gonna remind you that I am aware that this is the time when you'll start turning in assignments. So I'll be more vigilant to get your stuff graded in ahead of meeting that deadline in December. So with that, and if there are any questions, always ask away. Cool. Then we'll continue with Hyper-V. And then we have 2 chapters based on high availability. So chapter number 7, Hyper-V Part 2. As you have seen with working with the desktop, you have 3 main types of virtual hard disks: the fixed sized, which won't increase; the dynamically expanding, which is the more preferred. It says it's slower, but it's really fine for most applications, unless it is a disk intensive application, such as database. If you have a database VM, you more than likely want to use a fixed sized. And then there's differencing. Sorry. New disks are easily created with the wizard. You'll either do the VHD for any old type of VM, like you're running XP or older, a VHDX for the current, and you can do VHD set if you're sharing the disk in a cluster. And there's the wizard. And the VHD set is something new, so anything other than Windows 10 won't necessarily work with it. You'll choose your disk type. You'll say how big, if it's a file, or if you're actually connecting a physical disk. They are typically created in the default location unless you choose another path. And then once it's created, then you can use that same wizard to edit a virtual hard disk to either compact it, convert it, expand, merge, or reconnect. A pass-through disk is essentially a physical disk that's connected to a VM. It lacks the flexibility because it's a physical disk on the other side. And you're limited to a 2 terabyte size. But it is possible to connect a physical disk that's attached to the host to a virtual machine direct. And that's where you define it. Within, you would add the hard drive and say, hey, here's my physical disk that I want to connect. There is a storage QoS to set performance values. It will affect other VMs if you have multiple VMs running on the same host, and can be set on either the IDE or SCSI. So good to set up for critical infrastructure, but know that other VMs on the same drive will feel that effect, especially when there's a lot of read and write happening. So within the SCSI controller, you can define the quality of service and see the minimum number of operations that can happen and the maximums. The two main policies are the aggregated and the dedicated. Setting the dedicated will set your minimum and maximum. Your aggregated will set that to a set of virtual disks, whereas dedicated will be for each specific disk. Your virtual networks will function in the same way, especially if your drives are your hard disks, your virtual disks are on the network. They'll also have that same functionality. In Hyper-V, you have what's called the external virtual switch. That is what basically will connect the virtual world with the physical world. And you can only have one external switch per physical network adapter. You should have more than one NIC installed on a host, just because there's a lot of traffic that can come out of VMs, especially if you have a lot of VMs on the network, you're gonna have a lot of traffic. So it's a good idea to have multiple NICs to either load balance or have a failover or just have more bandwidth. All right, so once you set a NIC as the external virtual switch, Windows will bind it and unbind any other protocol. So it becomes essentially dedicated to being the outbound and inbound for that switch. So you see when it's not part, then they can do anything and everything. But once it becomes bound to it, it will be it'll be the gateway out, essentially. Your internal virtual switch allows your VMs to communicate to one another. Because it's internal, it's all happening on the CPU. So all the traffic is completely virtual. It works the same way, getting addresses from a DHCP server, either internally or externally, or it could be completely isolated. You can see and talk to other hosts on the same subnet, but it's all virtual. It's all on the CPU. It's not at all going out to the world. So great if critical infrastructure is necessary, and there's a number of VMs that make up your critical infrastructure. They can communicate with each other at high speed without the need of fiber or other really expensive networks. Now, the traffic that occurs between these two will only run through the CPU and never get out. You can make private virtual switches. Similar to internal switches, except the VMs that are connected to this private virtual switch cannot communicate with the outside world. It's basically an internal switch without a way out. So there's the NIC pointing out to the world, but a private switch will only connect VMs together and not out. So great for testing, great for, like I said, an internal communication that does not need to talk outside. You still get all the benefits of the high speed communication, just no connection out. You can connect an external and a private switch. You can also create internal virtual switches with routing if you have an isolated network and then you want to join it. And this is all true because the virtual network is exactly that. It's all software based. So changing configurations is way easier than doing a physical switch and adding more devices and more cabling and whatnot. All software based makes it easy to make these changes. Just like with other items, creating a switch is done through a wizard. So you create a new switch, it'll ask what kind of switch are we looking to create. You give it a name, any notes, information, and VLAN if necessary. You know, as with any adapter, any NIC card, you have to have a MAC address. You can have Hyper-V dynamically create these or use a pool yourself. So there's the global network setting. And again, you can extend it if you like. If you have more VMs than MAC addresses. Your virtual NICs are always created when a VM is launched or you add one or you import a VM in. Because it's all software based, it's easy to remove, disconnect, do anything. So here you can add a network adapter. Once it's created, you can set up to what switches it's connecting, any VLAN, any bandwidth management. Switches can help with other configuration tasks like hardware acceleration. There's advanced VNIC features. There's NIC teaming. This is synthetic versus the network adapter and fiber. So hardware acceleration, you have the VM queue, virtual machine queuing, the IPsec task offloading, and the single root IO virtualization or SRIOV. With VMQ, we can accelerate the performance by delivering packets from the external network directly to the VNIC. So any traffic that is destined to a certain VM will get priority. We have the IPsec task offloading. Any IPsec security associations will be offloaded. And SRIOV will enhance the performance by bypassing the virtual switch and communicate directly with the physical hardware. All different ways of handling the traffic that's coming in and out and dealing with it quicker. Did I go backwards? I think I did. Yep. Your advanced features that come with your virtual NICs, because it's all software based. You know, the MAC address, we can spoof if needed. We have DHCP and router guards. We can make protected networks. We can mirror any ports if we want to do packet analysis and device naming. All available within the advanced features. We can also do NIC teaming, great when we have critical infrastructure that needs to communicate to the outside world, and we want to give it as much bandwidth as possible. You need at least a second NIC. They can handle load balancing. They can handle failover. You can set all that stuff out in Hyper-V. And some of this can be done with PowerShell in either the Server Manager or PowerShell. Here it is within Server Manager. You have three main teaming modes: the switch independent, the static teaming, or LACP. When it comes to load balancing, we can do address hashing, the Hyper-V port, or dynamic. Virtual machines will have the same procedure as physical computers. If we're choosing to establish disk teaming in the guest OS to provide redundancy, we can enable this. The switch embedded teaming, or SET, is a new feature to Hyper-V that allows up to 8 physical adapters to be configured as a team. So again, great for very fast and huge bandwidth for 8 NICs to work together as one. It supports the remote directory memory address for virtual network adapters. And of course, that has to be enabled on the host system who has the up to 8 adapters, or the 8 NICs. The synthetic network adapter is available on Gen 1 VMs if integration service is installed. Gen 2s don't support legacy network adapter. With Gen 1s, if your OS doesn't support the synthetic network adapter or you need PXE boot, then you'll need to use Gen 1. Otherwise, Gen 2 will be your way to go. Synthetic is just another way of saying, a better NIC than the legacy. And it is possible to connect a fiber channel storage directly from a VM or clustering VMs and connecting them into a SAN. And you can add that as well. You can connect that fiber adapter into a VM to give it that capability. It is possible to do nested virtualization if needed, which is basically running a VM within a VM, not a container, but another virtual machine within a virtual machine. Hyper-V isn't able to do any VM within a VM, but it can do some. And obviously, you can't use dynamic memory since 2 VMs are running. And you can't live migrate one that is running a Hyper-V. Hyper-V does run Linux systems, so don't feel that Hyper-V is a Windows only, especially with Azure. It is possible to run any and all OSs. Cool. Any questions? Okay. So we'll